Hello, Royals. For lesson 2.5, on transformations, let's just do more examples. So we learned that what we've been using for vertex form for quadratics is actually just a specific case of transformational form for any type of function, where we may have seen our direction of opening and our axis of symmetry and our optimal value. We now just need to replace it with the transformational words we should have learned in grade 10 anyways. We have a vertical reflection if A is negative. We have a vertical stretch by the absolute value of A, horizontal translation or shift. In the general case, assuming that we see X minus, P is positive, we'll say right P, and vertical shift or translation up Q. Okay, we will talk about why that reversal occurs one more time here. So let's try sketching, I don't know, g of x equals 1/4 times the square root of x minus 2 minus 3. I think I'll work my way up here and sort of show the different transformations as I go. So I want to start with my parent. I recognize my parent function. There's no bracket and then a square here, so I'm not transforming a quadratic. It's a square root of. I'm transforming a parent radical. Vertical out of the origin, please. Your transformations have to follow the order of operations. Your vertical stretch occurs first. You are going to be dividing your heights by 4. I've just drawn a vertical reference line here. Every single point is now going to be 1/4 of its original height above there. Now, do you notice how ridiculously difficult this is to draw? I need to convince my reader that it's coming out vertical there. So what I'm going to do is I'm going to zoom in here and pretend that this is actually the portion that I'm drawing. I'm zooming in there and then stretching my scale out, not my curve out, so that I can still draw a parent radical curve that looks something like that. And instead of, say, having the point, I don't know, 1 comma 1 on here, this right now is the point 1 comma 1/4. How do I know that that's 1 comma 1/4? It doesn't look like one. It's 1/4 because I say so. Again, I have that power. The point 4 comma 2 used to be on here. That y value of 2 is going to be quartered down to, what's 1/4 of 2? Well, 1/2 of 2 is 1, and then another half would be 1/2. So here's the ordered pair 2 comma 1/2. And what I've drawn here is the sketch of y equals 1/4 times, I don't know what's wrong with me today, or in general. Y equals 1/4 times the square root of x. Got it? Let's just talk about the reversal on its own. Here, x would have to be greater than or equal to 0. If you are subtracting 2 from x before you try taking its square root, that means that you can now substitute in x values that are 2 larger than they used to be. Think about it as solving an inequality. You need x minus 2 to be greater than or equal to 0. To isolate that x, you will be performing the inverse operation. I don't want you to just remember that it's the opposite of this number and you're going right because it's on the inside. You should understand why. We translate this curve right to, I think I'm done labeling other key points, and then we translate it down 3 units. This is kind of a mess over here, isn't it? So maybe I should draw a nicer sketch. Maybe I don't care so much about my y-axis. Maybe I just draw a curve that is vertical at its point of interest. You could call it a vertex if you like, but I don't think you want to. It has coordinates 2 comma negative 3. I'm labeling that because it's an endpoint. Now the x-axis will be around here somewhere. And to try to solve for your x-intercept, you could set y equal to 0, and we can do that. We could try solving for that now if you like, but the question didn't ask us to label intercepts. Maybe in grade 10 you were always labeling x-intercepts because that's kind of how you did a lot of your sketching, but not all of your quadratics had x-intercepts either. Maybe the value of x that makes this output 0 isn't the most important value in the world. Let's pretend the question asked us to find the x-intercept. We would set g of x equal to 0, that means that 0 would have to equal 1/4 times the square root of x minus 2 minus 3. And you're going to solve for x as if it's a linear equation by undoing these operations in reverse order with inverse operations. You add 3 to both sides. You could multiply both sides by 4. Gives you 12 equals the square root of x minus 2. You square both sides. 144 is going to be equal to x minus 2. And then you add 2 to both sides. X is going to equal 146. 146 minus 2 is 144. The square root of 144 is 12. 1/4 of 12 is 3. 3 minus 3 is 0. Okay, so this x-intercept is 146. And once again, this is 146 because I say so. I am not going to say, oh, if this is -3, then 146 needs to be out of space already. This may be one of the reasons why I don't ask you to label x-intercepts. They might be kind of silly. What's happening here is this vertical stretch by 1/4 makes the curve so slow. I mean, it's still vertical out of that key point there, but it's going to cross the x-axis eventually. It has to. It grows forever. It's just kind of taking its time to get there. Okay. Let's try something with a reciprocal curve. Let's do, I don't know, let's sketch j of x equals, what did we do in class? +3. Let's do the reciprocal of x minus 2 minus 4. Okay. So here, reading the transformations is going to feel a little bit different with y equals a times x minus p squared plus q. You see the vertical out front, the horizontal shift inside, the vertical shift outside. The formatting on a radical is pretty much the same. You're just replacing bracket square with square root of. Okay. The reciprocal curve is a little bit different though. The horizontal transformations still occur next to the input. Those are happening in the denominator. Your general format for transformations of a parent reciprocal are x minus p plus q. Okay. So this is a parent reciprocal curve that has been translated right to and down for. Let's talk about why is it right to? Well, for this function, I'm not allowed to divide by 0. For any function, I'm not allowed to divide by 0. The value of x that would look like I was trying to divide by 0 would be 0. That means that x can't be 0. Well, now I can't divide by 0 still, which means that x minus 2 can't be 0. And once again, to isolate there, I'll be performing the inverse operation. If I'm subtracting 2 from my input before I reciprocate it, it means that my input can't be 2 larger than what it used to be. That explains why we are shifting to the right, not to the left. My advice for you here, again, maybe don't worry so much about centering on the origin and having the original curve and trying to track this point right to and down 4. Is this point really that important of a point? Why don't we instead, do you see how our original curve was framed by its asymptotes? Why don't we center our screen or our sketch on the point of intersection of the asymptotes? You're going to have a vertical asymptote of x equals 2. That's what happens when you move your old vertical asymptote right to. You're going to have a new horizontal asymptote of y equals -4. That's what happens when you take your old horizontal asymptote and shift it down 4. This curve used to hug in the top right and bottom left quadrants. It will still be doing that because it hasn't been reflected. Any stretches, I really don't care about here either. I mean, I would just argue that I've changed my zoom. You might want to let go of having to see the x-axis and the y-axis. Is it really bugging you that you don't see them? If so, then here you go. Here's your x-axis, and here's your y-axis. Does that feel better? I'm sorry, I don't mean to make fun of you, but yeah, has it really helped? Seeing where those are? What if this was shifted down 44 and this was shifted right 222? Do you still need to see those axes? Do we care what the x-axis or what the x-intercept is? You could do that. Why not? We've got some time. But here's my sketch. And from my sketch, I can state my domain and range. You want to find an x-intercept? Let's see how this goes. I'm going to set j of x equal to 0. That is always true anytime I'm trying to find an x-intercept. Memorizing that it's like the opposite of that number, or trying to take what I've memorized from quadratics in grade 10 and applying it here isn't going to work well. Focus on the definition. Yeah, so we would need the reciprocal of x minus 2 minus 4 to equal 0. Let's isolate for x. I'm going to start by undoing the subtraction by 4. I'll add 4 to both sides. This is not a subtraction by 2. It's a subtraction in the denominator here. I would like to isolate for x in the numerator. I think the next thing that would happen here, like the last operation that happens is a subtraction by 4. The operation that happened before that was a reciprocation. Let's undo a reciprocation. The interesting thing is to undo a reciprocation, you reciprocate. And then I'll undo a subtraction of 4 by adding 4. How about we just write this as 2 and 1/4? That'll work just fine for me. So here's your vertical asymptote, x equals 2. There's my x-intercept, 2 and 1/4. Again, like, does that add to the accuracy of our curve? I would say no. So don't bother finding x-intercepts or even y-intercepts unless you're asked to, or if you think it's really, really fun. But seriously, on a quiz, you'd be wasting your time, I think, if you're doing these kind of things. J of 0 is going to be the reciprocal of 0 minus 2 minus 4. That's going to be negative 1/2 minus 4. How about negative 4 and 1/2? Here's the horizontal asymptote y equals negative 4. There's negative 4 and 1/2 for you. Okay. This is me showing you what you could do, not saying that you would want to on any given question.